On January 1st, 1987, a paper was published in the journal Nature which rocked the world of anthropology. Researchers Allan Wilson, Mark Stoneking, and Rebecca Cann used the then new science of genetic analysis to analyze the DNA in human mitochondria. What they found was evidence that humans on Earth can trace their ancestry back to a single woman who lived approximately 180,000 years ago. Learn more about Mitochondrial Eve, the mother of everyone, on this episode of Everything Everywhere Daily. This episode is sponsored by Audible.com. My audiobook recommendation today is The 7 Daughters of Eve, The Science That Reveals Our Genetic Ancestry by Brian Sykes. In 1994, Professor Brian Sykes, a leading world authority on DNA and human evolution, was called in to examine the frozen remains of a man trapped in a glacial ice in northern Italy. News of both the Iceman's discovery and his age, which was put at over 5,000 years, fascinated scientists and newspapers throughout the world. But what made Sykes' story particularly revelatory was his success in identifying a genetic descendant of the Iceman, a woman living in Great Britain today. You can get a free 1-month trial to Audible and 2 free audiobooks by going to audibletrial.com/everythingeverywhere or by clicking on the link in the show notes. To start, we need a bit of background on how human genetics work. Most of your genes are some combination of your mother and your father. What genes came from who can differ, so even siblings or fraternal twins can look very different, even though they have the same parents. This mixing of genes is why sexual reproduction is so successful as an evolutionary strategy. However, not all genes can be combined in such a manner. The mitochondria, which is the energy-producing center of our cells, have DNA that only comes from our mother. That means me, you, and everyone in the world will have that particular bit of DNA in common with our mother. It isn't something that is recombined with DNA from our fathers. That means the DNA in our mitochondria doesn't change very much over time because it isn't recombining during the process of reproduction. However, it does change a little bit over time. Those are mutations that occur naturally. These mutations statistically occur at regular intervals. By determining the rate of mutation, you can create a type of molecular clock and work backwards to determine how long it was since different DNA diverged from the same DNA. It was using this technique that researchers determined how far back it was since we had our last common female ancestor. What they determined is that it was a woman who lived about 180,000 years ago, give or take a few tens of thousands of years, and she lived in Africa. She was dubbed Mitochondrial Eve. There's one other thing we know about her. She must have had at least 2 daughters. Why? Because if she had 0 daughters, she couldn't have passed along her mitochondrial DNA at all. If she had 1 daughter, then her daughter would be our Mitochondrial Eve. This technique has led to some surprising conclusions and overturned many theories in anthropology. First, it lent a great deal of credibility to the out of Africa hypothesis. This theory holds that humans developed in a single place in Africa and then left Africa in one or more migrations to populate the rest of the world within about the last 200,000 years or so. This is the dominant theory today, and it's supported by most evidence, especially genetic evidence. Prior to the use of genetic evidence, the multi-regional hypothesis had many adherents. This held that humans had a common ancestor about 2 million years ago, and then spread around the world and evolved separately. Second, it helped narrow down exactly where in Africa Mitochondrial Eve might have come from. Based on an analysis of genes of current human populations, and based on 3,000-year-old remains, it's believed that Eve came from the region of what is today the Kalahari Desert in southern Africa. The term Eve obviously comes from the Bible, and as such there's some confusion over what the term Mitochondrial Eve means. Mitochondrial Eve was not the first human or the first woman. She also wasn't the only woman when she was alive. Other women alive when she was simply didn't have female descendants who made it to today. That was totally due to chance. She is simply the most recent common female ancestor that every human has on Earth today. Moreover, and this may confuse many people, Mitochondrial Eve can change over time. As I just said, Mitochondrial Eve is defined to be the most recent female ancestor we all have in common, who we can identify via our mitochondrial DNA. Over time, with increases in populations, people moving and intermarrying, genetic populations become mixed, and that person who is the most recent ancestor can change. But the fact still remains that we would still have a single recent ancestor that shares our mitochondrial DNA. As I mentioned, only females can transmit mitochondrial DNA. You might be wondering, is there an equivalent ancestor for males? And the answer is yes. The male equivalent would be DNA passed in the Y chromosome. This is only passed from males to other males. So, is there a Y chromosome Adam who is the counterpart of the mitochondrial Eve? Again, yes. However, the Y chromosome Adam and the mitochondrial Eve were not hanging out in some genetic Garden of Eden at the same time. In fact, they didn't even live remotely close to each other. It's estimated that Y chromosome Adam may have existed about 60,000 years ago, as opposed to mitochondrial Eve, who existed 180,000 years ago. How is this possible? Shouldn't they have been at least somewhat contemporary? Well, no. It all has to do with reproductive potential. Not even factoring in children surviving to adulthood, there's a limit to the number of children a woman can have in her lifetime. For example, an 18th century Russian woman holds the known record for having given birth 27 times in her life, with several multiple births. However, there are many examples of chiefs, kings, and emperors who had fathered hundreds of children. Genghis Khan, who lived only 800 years ago, may have fathered thousands of children. Genetic testing has shown that 8% of all men currently living in the former Mongol Empire are direct descendants of Genghis Khan, which means that at least 1% of everyone in the world today is descended from this one man who lived only centuries ago. These superfathers are why there is such a time difference between our genetic Adam and Eve. And just like our mitochondrial Eve might change, so too will our Y chromosome Adam. In fact, in the future, it might very well become Genghis Khan. To top it all off, I've been very specific when talking about both of these types of genetic ancestors. I've only discussed the specific origins of specific DNA. That doesn't mean, however, that these are our most common recent ancestors. If you do the math, the number of ancestors we have doubles every generation. You have 2 parents, 4 grandparents, 8 great-grandparents, etc. Assuming you have 25 years between generations on average, you quickly get to a point where we have billions of ancestors, which is much larger than the number of humans which ever existed. That means the most recent common ancestor might have only existed about 3,000 to 5,000 years ago. This person might have been a male or female, and statistically would have probably lived in southern or eastern Asia. It's hard to track this person genetically because, as I mentioned above, genes get mixed, and we can't track this as well as we can with mitochondrial DNA or Y chromosomes, which are only passed by a single sex. The thing which really lowered the date for the most recent common ancestor was the expansion of Europeans into places like the Americas, Australia, and the Pacific several centuries ago. So when you hear someone say that all of humanity is one big family, it isn't just some crunchy granola kumbaya slogan. It is the literal truth. All of us, you, me, everyone listening to my words, are all very distant cousins of each other. Executive producer of Everything Everywhere Daily is James Makala. The associate producer is Thor Thompson. Today's 5-star review comes from Podcast Republic listener Matthew, who writes, "Interesting, eclectic, I love it." Well, thank you, Matthew. I'll take it. And thanks to everyone who's left reviews and who has shared the podcast with their friends. Let's face it, you all have at least one nerdy friend who would love this type of show. Share it with them and spread the nerd.